Hello, welcome to our lesson on applications of differentiation, and today we are going to look at stationary points. Okay, so when we talk about stationary points, what are stationary points? Okay, so there are points on a curve. So let's say when you have a curve, with my y-axis, my s, and when I have a curve, okay, let me extend this. When I have a curve like this, okay, the stationary point is a point on the curve where dy on the x, okay, is equal to 0. So where can we get dy on the s to be equal to 0 on the curve? Okay, dy on the x, we know that is the gradient function. So when I substitute x, the value of x or the value of y into the gradient function, and then the gradient function gives me 0. All right, it is telling me that the gradient of the tangent is 0. Okay, and where can the gradient of the tangent be 0? So we know that the gradient can be 0 if the tangent is parallel to the s-axis. So if the tangent is parallel to the s-axis, let's say I have on the s-axis, what is the value of y? The value of y is what? Is 0. Then it means that whenever the tangent is what? Is parallel to the x-axis, the value of y is what? The value of y is 0. Okay, it means that there is no change in what? No change in y, but there is what? A corresponding change in x. Okay, so where can we get the tangent to be parallel to the s-axis? That to be at the turning point, this particular place, the point here, or at the minimum at the point here. All right. So the point here or the point here, you get it. Okay, so at the point here, this point is where the curve will be at the maximum, so maximum point, and then here the curve is at what? At the minimum. So here you say the minimum point. All right, you say the maximum or the minimum point. And anytime the curve is decreasing, okay, you may have the gradient to be negative gradient. And take anytime the curve is increasing, like this one is increasing, okay, you may have what? A positive gradient. Is that okay? All right, so this is what is going to happen. So we can, at the maximum point, dy on the x is what? Is 0. All right, and at the minimum point, dy on the s is also what? Is also 0. Okay, so and then we have said that when the curve is decreasing, the gradient function is negative. When the curve is increasing, the gradient function is what? Is positive. Okay, so where the at the left hand or the right hand side of the maximum or the minimum point, and then the value of the gradient become the same. Okay, then we say that that is the point of what? The point of inflection. Okay, that is the point of inflection. All right, so how are we going to get the maximum or the minimum point? Okay, so when you are given a function for a curve, what you are going to do is that you differentiate the function, okay, and then you equate it to what? You equate it to 0. So that when you equate it to 0, you find the value of the x. Okay, when you differentiate the function, you equate it to 0 and find the value of the x. When you find the value of the x, when you want to get the corresponding y value, what do? You substitute the value of the s into the main what? Into the main function. For instance, if I'm giving y is equal to, let's say, 3s cubed minus 2s squared plus 5. I'm just using this as an example, and I want to find the maximum or the minimum point where the gradient function is 0. So my dy on the x. Okay, so I'll multiply 3 by 3, that will give me 9x squared. 2 by 2, that will give me 4x. This will give me 0. Okay, then with this, what we are going to do is that you solve this particular function here, okay, by equating to 0. Because if you want to get the maximum or the minimum point, at that point the gradient function is what? The gradient at that particular point, the gradient of the tangent is 0. It means that when I put the value of s into this function, it will be what? It will be 0. So it means that 9s squared minus 4s is equal to what? Is equal to 0. Then here, what can we do? We factorize x out, then we have what? 9x minus 4 to be equal to 0. Alright, then either your x is 0 or you see that 9x minus 4 equal to 0. Okay, which will mean that x will be equal to what? 4 or 9. So you got two values of x. It means that these are the values of s at where the gradient, okay, is 0. Okay, the gradient is 0. So what you do to find the corresponding y value so that you get the point? Okay, so what you do is that you take this particular, the value of s, then you substitute into the main function here. Okay, so I'll take the value, say s is 0, say y is equal to 3 0 cube minus 2 0 squared plus 5. So y will be equal to 5. So my point to be what? 0, 5. That is s is 0, y is what? Y is 5. That is if s is 0. Then you do the same thing for if s is what? 4 over 9. So you realize that we are going to get 2 points. And the 2 points, one will be the maximum value and the one will be what? The minimum value. Is that okay? That is what it's going to what? It's going to be mean. Alright. So if you want to get the maximum or to know the point which is maximum or minimum, then what you do is that what? You further differentiate. Alright, you further differentiate. So if I further differentiate, which is f prime prime of x, okay, we know that's what? The square y over the s square. Then you further differentiate. So if I further differentiate and then I get it to be less than what? Less than 0. Then that point is what? The maximum point. Is that okay? When you further differentiate and then the value that you get is less than 0, then at that particular point, the point there is what? Is the maximum point. So what we have here, you differentiate again, that is the square y over the s square. You differentiate this particular function again. Okay, then when you differentiate the particular function, then you find the value of the x there. Then when you find the value and the s is less than 0, then it means that that is the maximum one. That point is the maximum point. Then if you further differentiate and then the square y on the s square is greater than 0, then instead that point is what? The minimum point. Okay, the value that you get, then that point is the minimum what? The minimum point. Okay, the minimum point. But if you further differentiate and then the square y over the s square is equal to 0, then it is the point of inflection. Okay. So if the square y over the s square is equal to 0, then that is the point of inflection. Is that okay? So that is about the stationary points, okay, where you find the maximum point or the minimum point. And you want to find the maximum or the minimum point, then you have to differentiate. It means that the differentiation function is equal to what? Is equal to 0. Then you find the value of s there. Okay, that the value of s where the gradient of the tangent to be what? Will be 0, and it will be 0 at either the maximum or the minimum point. And if you want to determine the maximum or the minimum point, then you further differentiate. If you get the value to be less than 0, then that is the maximum point. If the value is greater than 0, then that is what? The minimum point. Okay, if the value is equal to 0, that is the point of what? The point of inflection. I believe you get it. Okay, so we are going to solve question on the stationary point. All right. Okay, So let's look at the questions. Number 1, we have to find the stationary points of y is equal to 1 over 3s cubed minus 2s squared plus 3s and identify their nature. Okay, so here what we are going to do is to find the stationary points, mean that we are going to find the maximum and then the minimum point, or if there is even a point of inflection. All right, so we have y to be equal to 1 over 3s cubed minus 2s squared plus 3x, and at the maximum or the minimum, our dy on dx is equal to what? Is equal to 0. So first we have to find dy on dx. Okay, so we bring the 3 here. So 1 over 3 times 3 will cancel 3, so to give us 1. So here will be, this place will be 1, then we subtract 1 from here, so it will be s squared minus 2 times 2 will give us 4x, then plus what? Plus 3. Okay, so our dy on dx is s squared minus 4x plus 3, and at the maximum or the minimum, dy on dx is equal to 0. Alright, so therefore s squared minus 4s plus 3 is equal to 0. Then we have to what? We have to factorize, and then we get our value. So the coefficient of the s squared is 1 times 3. We are going to get 3. 2 factors of 3, that will give us negative 4. You can get negative 1, negative 3. Alright, minus 1 times minus 3 is 3. Minus 1 minus 3 plus minus 3 is what? Is minus 4. So we can write as what? S minus 3, S minus 1 equal to 0. Alright, S times S is S squared, S times minus 1 is minus 1, X minus 3 times X is minus 3. So minus 1 plus minus 3 will give me minus 4, and then minus 3 times minus 1 is 3. Okay, so our X minus 3 will be equal to 0, which implies S equal to what? 3, or S minus 1 equal to 0, which implies S equal to what? 1. Alright, so the values of S are either S is 3 or S is 1. Alright, so what we have to do is to find, we are finding a point. So at the point where S is equal to 3, that is where this particular curve here is at the maximum or the minimum, or where S is equal to 1. But we have to find the corresponding Y value. So what do? We will substitute this value into the main function, and then we find the corresponding value of Y. And then we also do that for 1, and then we find the Y corresponding value for Y. Alright, so let's do that. So we say that if S equal to 3, then it implies that Y is equal to what? 1 over 3 key minus 2, 3 square plus 3 multiplied by 3. So this is what we are going to have. Then we use the calculator. Alright. Okay, so let's continue. Y is equal to, so we substitute the value of S into the main function here. So 1 over 3, then S cubed 3 cubed minus 2, S squared, then 3 squared plus 3 multiplying X. So let me do that. Over 3. So we are going to have Y to be equal to 0. Alright, so we have Y as 0. So that particular point is what? Is 3, 0. That is, if S is 3, Y is what? Y is 0. So this point may be the minimum or the maximum. We don't know, unless we further differentiate, and then we know if it is minimum or what? Maximum. Okay, then we will say that if X is equal to 1, then we are going to have Y as what? 1 over 3, 1 cubed minus 2, 1 square plus 3 multiplied by 1. Okay, so let's test this one too, and then we see. So we have 1 over 3, 1 cubed minus 2 times 1 square plus 3 times 1. Okay, so let's see what we are also going to get for that one. That one, we are going to have Y to be equal to 4 on 3. It implies that the point there will be what? 1 and then 4 over 3. Okay, so the point there is also going to be 1 and then 4 on 3. Alright, so we have gotten the 2 points. 3 0 and then 1 4 on 3. Okay, but we have to determine, he said we should state the nature, so we have to determine the maximum, or the one which is maximum, or the one which is what, minimum. Okay. So to determine the maximum or the minimum, we have to what, further differentiate this. The differentiation of this is this, so we have to further differentiate. So if we differentiate and then the answer we get is less than 0, then it is that particular point of the maximum. If it is greater than 0, then that particular point is of the minimum. Okay, so the square y over the s square will give us what? That is, we further differentiate this. So this will give us what? 2x minus 4. This will be 0. So if you differentiate this, to give you 2s, and then this will be minus 4. Alright, then we have to substitute x. So if x is equal to, from here, if s is what? S is equal to 3. It implies that we have what? 2 times 3 minus 4, and that will give us what? So 2 times 3 minus 4, 2 3 6 minus 4, that will be 2. Alright. So this is what? This is greater than 0. So it is telling you that this particular point of what will be the minimum point. Alright. Okay, so let's also check the other one. That one too, if s is equal to what? 1. That one will be what? 2 times 1 minus 4. 2 1 2 minus 4. That will be negative 2. Alright. Okay. So let's continue on this side. Okay, so now let's check and see, so that we know the maximum or what? The minimum point. Okay. So at point at point 3 0. So what happened to our d square y on the s square? Okay, what do we get for our d square y on the s square? We had what? At this point, if s is 3, we had positive 2. So that means it is greater than what? Is greater than 0. Okay, if it's greater than 0, then it is telling us that this particular point is the minimum point. So it implies that point 30 is the minimum point, as we have learned. Okay, and also at point 1 4 on 3, the square y on the s square is also less than 0, because we had what? When s is 1, we had the answer to be negative 2. It means that the point 1 4 3 is the maximum point. Is that okay? So this particular point here is the maximum point. So when you get a question like that, and any time the square y over the s square is greater than 0, then it means that that particular point there is the minimum. If it's less than 0, then it is the maximum. I believe this is clear. Let's go to number 2. So number 2, the curve y is equal to s squared minus as plus b has turning point at 1 3. Find a and b. Okay, at the turning point, that is where the curve is at the maximum or the minimum. So at the turning point, if the curve is at the maximum or the minimum, then the y on the s is what? Is equal to 0. Okay, and we are giving this to find the value of a and b. And then the curve has a turning point of 1 3. Okay, and at the turning point is also a point on the curve. So since we are supposed to find a and b, then what it means that we will have to get simultaneous equation, and then we solve to find the values of a and b. So one, we have y to be equal to s squared minus ax plus b. Okay, so this is the curve. Y is equal to s squared minus as plus b at this point. Okay, the curve is at this point. On the curve we can get a point 1 3. So it means that at point 1 3, what does it mean? It means the s value is 1 and the y is what? Y is 3. So we can say that 3 is equal to 1 squared minus A multiplying by 1 plus B. So that is what you can see. Okay, because this point is on the curve. So 3 is equal to 1. 1 square is 1. Minus A times 1 is minus A plus B. Alright. So let me take the variable here and bring the constant in. Okay. So then I'll have what? A minus B equal to 1 minus 3. So that A minus B will be equal to what? Minus 2. Let me call this equation 1. So my A minus B is equal to minus 2. And that is equation 1. Okay. Then I come and consider the turning point. What happens at the turning point? At the turning point, dy on the x is equal to 0. But the turning point is where the curve will be at the maximum or the minimum. Alright. So if dy on the x is equal to 0, then my dy on the x will be equal to what? 2x. And then here a is constant. Okay. So minus a. And then the b will be 0. Alright. So it implies that my 2s minus a is equal to what? Is equal to 0. So at the turning point, this particular the dy there is equal to 0. But at the turning point, what is the value of x? The value of x is 1. Okay. So x is 1. It implies I can say that 2 times 1 minus a is equal to 0. And I have what? 2 minus a is equal to 0. Okay. Then I have what? 2 to be equal to a. So therefore my a is what? My a is 2. So the a is 2. And I'll substitute the value of a into equation 1. Then I'll get what? The value of b. Alright. So put a into equation 1. So 2 minus b equal to negative 2. 2 minus b equal to negative 2 because a is 2. So I have for minus b to be equal to minus 2 minus 2. Then minus b will give me what? Minus 4. Therefore, what to be my b? My b is going to be what? 4. So divide here by negative and here by negative 1. So we can conclude that therefore a is equal to 2, b is equal to what? 4. So my a is 2 and my b is what? My b is 4. Alright. So let's look at the last question. Okay, so let's look at the number 3. The function f of x equal to a squared plus bs plus c has gradient function 4s plus 2 and a stationary value of 1. Find the values of a, b, and c. Okay, so this is a quadratic function and the gradient function is 4s plus 2. So if you differentiate this, you get 4s plus 2. And the stationary value stand there for what? The value of the maximum or the minimum. Okay, the y value, okay, becomes what? The stationary value. So if you hear the maximum value or the minimum value, it is the y value, okay, of the maximum or the minimum. Okay, so that's the stationary value. All right. So let's see. We are given f of s, so we can say y, okay, is equal to as squared plus bs plus c. Then we are saying that the gradient function of this, so dy dx of as squared plus bs plus c will give me what? 2ax plus b. This will be 0. So this one is equal to 4s plus 2. Alright. So it implies that 2ax plus b is equal to 4x plus 2. Because this is the gradient function if you differentiate this. So this is equal to 4x plus 2. So we can compare coefficients and then we can find the values because we are supposed to find the values of a, b, and c. So here, the coefficient of x here is 2, the coefficient of x here is 4. So you can say that therefore 2a is equal to 4, which means what? A is equal to 4 on 2, which is 2. So a is 2. And then we can also say that the b here is equal to what? So my b is also equal to 2. Okay. So we have gotten the value of A as 2 and the B as also 2. Okay, so I have my A as 2 and my B as 2. So I can rewrite the function as y is equal to 2x squared plus 2x plus c. Alright, and we're given the stationary value as what? As 1. And what you should know that the stationary value is the y value at which the curve is at the maximum or the minimum. Alright, so that is the stationary value. And if the curve is at the minimum or the maximum, what's happening is that the gradient function is equal to 0. The one here is equal to 0. So it means that this particular function 4x plus 2 is equal to 0. So that we can find the corresponding value of x at the maximum or the minimum where the value of y is what? Is 1. So that we can use that to find the value of the c. So we have 4x to be equal to negative 2. Alright, and then my x will be equal to what? Minus 2 on 4. And what is minus 2 on 4? That is minus 1 over 2. So my x is negative 1 on 2. So at the point where the curve is at the maximum or the minimum, x is what? Negative 1 on 2. And y is what? Y is 1. Alright, therefore the stationary point have to be a stationary point. Minus 1 over 2 and then 1. Okay, so the stationary value, the y value, actually the curves at the maximum or the minimum 1. Alright, so we can substitute the s and the y into our function here and find the value of the c. So what is our 1 is equal to 2 times minus 1 over 2 squared plus 2 times minus 1 over 2 plus c. Alright, so we have 1 to be equal to, what is 2 times minus 1 over 2 squared plus 2 times minus 1 on 2. That will give us the same minus 1 on 2 plus c. So we can say that 1 plus 1 over 2 is equal to c. So that what will be our c. 1 plus 1 on 2. 1 plus 1 on 2 is what? Is 3 on 2. So the value of c is what? Is 3 over 2. So the value of c is 3 on 2. So we can say that therefore our a is 2, our b is what? Is also 2, and our c is 3 over 2. I believe you get it. Alright. Thank you for your time. I know I will see you again in our next lesson. Bye bye.